both of these answers, by the way, different. That's kind of weird. You can prove this identity, by the way, that sec plus tan equals 1 plus tan x on 2 on 1 minus tan x on 2. It's not that hard to prove. But there's one thing missing off both of them, which is this. Now, I'll freely admit, I've been kind of floating over this idea, but I should formalize it now. Really, this is how we should write things. Okay, now, put your pens down. As I explain this, and this will be the last thing because we're running out of time, you need to understand what's going on here, okay? One of my pet hates is people who have learned that when you integrate and you have a log, okay, you just put absolute value signs on. I remember the first time I asked someone, why do you put absolute value signs on? The answer I got back was, well, logs, right? You can only take the log of a positive number, can't you? It's log base e, and there's no power that you can raise e to, which will give you a negative number. And that's what logs are about, right? What power should I raise to, okay? And so, here was the answer I was given. You put the absolute value signs on to make it positive, because we want it to be positive. Now, I sort of bought it at the time, right? But that's a really terrible argument when you think about it. It's like, I put absolute value signs on, this is what the argument boils down to, because I want them to be absolute values. Like, there's no actual rationale for why it actually makes sense, why you can go from here to here, and it's actually you need to include the absolute values to make sense of half of your answers, okay? So let me show you why. Rule off where you've done this answer, because this is an important sub-idea on its own. We make statements about integration based on differentiation, right? We make statements at, wait, did I say it the right way? Statements about integration based on differentiation. So, things about logs, right? Well, I can say that the derivative of log x is equal to 1 on x, can't I? We've been doing inverse functions recently and inverse trig functions, and we know that something that you can normally not worry about, but sometimes is really important, is restrictions. There is a restriction on this, isn't there? What's the restriction? X is positive, right? Of course it has to be. Log x doesn't even exist when x is negative, but this does. How does that make sense? It doesn't. That's why you must restrict, okay? So on the basis of this statement, I can form an integral of this. Namely, the integral of 1 over x is log plus a constant. No props, okay? But log x has a brother which is defined for negative values of x, right? Namely, log of negative x. He's defined for x is less than 0, right? What is the derivative of log of negative x? Well, you do chain rule, right? You do the inside function, so you go, that's minus 1, right? And then you divide by, well, it's f dash on f, isn't it? Huh. What just happened? I'll tell you what happened. A restriction happened. Okay? So, what this means is, I made an integral statement on the basis of this derivative in this domain. I'm going to do the same thing here. Watch carefully, right? It's the same integral, 1 over x dx, right? But it doesn't end up on log x if you're in a different domain. It only ends up on log x in this domain, right? If you're not in that domain, you end up here. I'm just going backwards, right? I'm just following the argument, right? So in this domain, you get this log. In this domain, you get this log. And they're different, right? But I can combine them. I can say, therefore, this integral is equal to two different things depending on where you are, okay? It's equal to log x plus c, provided x is positive, okay? But it's equal to log of negative x plus your constant if x is negative, okay? But this here, this is the way we define the absolute value function, right? The absolute value function is equal to x when x is positive, and it's equal to minus x, negative x, when x is negative, right? So therefore, I can whirl these into one, like so, okay? So, please, 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 when someone asks you, you know, maybe one of your 300 friends is looking over your shoulder and be like, why have you got absolute values there? I don't have to worry about those, okay? Don't tell them it's because logs have to have a positive value. That's not true. This is the reason why, right? It's because when you consider under a different domain, when you restrict it in a different way, you get a whole different function. And this is our way of writing both. Okay? So that's why when you have something like this, you should have your absolute value sign to there.